Alrighty, good morning. This is Wednesday, June 3rd. This is A6 Algebra 2 CP. Hopefully you're having a great day so far, and I'm out here hoping to make it even a little better after this class. Today, what I would like to do with you is essentially, since we only have 2 classes to go, what I would like to do is review the fourth quarter topics with you on rationals. A big portion of the fourth quarter, actually the entirety of the fourth quarter, is spent talking about rationals, talk about rational functions when we talk about graphing, talk about rational equations with solving, and then talk about some word problems when we deal with those as well. Okay. So I'd like to kind of just recap and put a nice bow on everything that we've talked about for our fourth quarter of distance learning. I think it would be a nice way to sort of wrap it all up together. Couple announcements I want to make sure I deliver to you. Number one, make sure that you fill out the attendance form on Classroom if you didn't do so already. Make sure that your microphone is muted and your webcam is disabled, which everybody's gotten good at. Make sure that you submit any missing assignments if there are any outstanding assignments. I know in particular the most recent progress assessment, the fifth one, was somewhat lacking in submissions. I probably received about 75% of them, which is good. I don't want to discredit the 75% of people that turned it in, but at the same time, that means there's still 25% that have not. So please make sure that you get that to me if you haven't done so already. I'll still give you credit for your work, so please make sure you get that in. The last announcement I want to make sure I give before I go into this is the fact that we do have, for students entering pre-calculus specifically, summer work packets that you are required to complete. I know that sounds gross. I know you'll be like, ugh, Giorgio, why? The reason for the summer packet is not because we want to torture you during the summer. It's not because we want you to, sit inside and do math all summer. It's really to provide a nice refresher of certain key topics from Algebra 2 that will be used in pre-calculus. So factoring, for example, it's big in pre-calculus. Not surprisingly, it doesn't go away. It's on the summer packet because that's a topic that you should be fresh on entering pre-calc. The reason why we decided to implement those summer packets was because going into pre-calculus, it was expected that students understood how to factor. And just because they haven't done it in a long time, a lot of students are really rusty. And so a lot of time had to be spent going back and reviewing, and it added to the layer of confusion, or added another layer of confusion, rather, when people didn't already know how to factor, and then we had to review that, and then we had to learn something new on top of it. So we found that in the past couple of years with the summer packets, it's definitely been a little better where people are coming in fresh on their knowledge and able to just hit the ground running. It works better for me. It works better for you. It just is a win-win overall. Now, it's not designed to take an exorbitant amount to complete. I am going to send that out to you today, so you have it. I would highly recommend, since we have 3 lingering days next week that are designed to be intervention or catch-up days, if you do not have any additional work for your other classes, just bang out the summer packet and get it done. I mean, definitely make sure you review it before we start the next school year. Just like flip through it and review it. But hey, get it done. You have that amount of time, you might as well take advantage of it. I was a wicked bad procrastinator in high school, and even so, I think I'd still take advantage of that opportunity. So make sure that you get that done. The last note that I want to make sure I tell you about the summer work is, at least this year, you may remember way back at the beginning of the year that our very first progress assessment in Algebra 2 CP was based on the summer work that you received in geometry. You completed it over the summer, and we had a little progress assessment on it to start the year in Algebra 2. I don't know what the structure of school is going to be next year. I can't say if we'll be 100% distance learning, if we'll be back to school as normal, or some hybrid in the middle. But what I can say is I can't imagine that structure of the first grade of the next school year being the PA on the summer packet. I can't imagine that changing. So most likely that will be the case next year. So just be mindful of that. If you want to start off pre-calculus on a good note, make sure you get that summer packet work done. Now, I did keep mentioning that it's only for students taking pre-calculus. If you are taking other math classes like discrete math, like probability and statistics, like financial algebra, there is no summer assignment required for those classes. Okay? It's only because these core classes, Algebra 1, Geometry, Algebra 2, Pre-Calculus, and Calculus, directly bridge into each other. That's why those sort of catch-up assignments, or refresher assignments rather, are in place. All right. So if you're taking not pre-calculus next year, there is no summer work that you have to complete. But if you are taking pre-calculus, make sure you get it done. It's very important. I noticed, being that this was the first year that I taught pre-calc, I noticed a big significant effect with students that actually did the summer work starting off the first quarter. They were able to start a lot stronger versus students that did not do the summer work. Not surprisingly, they kind of had to already start out a little behind the eight ball. So make sure that you get it done. If you do have any other questions about it at any point over the summer, you can always feel free to reach out. All right, that's that long drawn out announcement on that. Does anybody have any questions about the information I just delivered before I jump in and review the concepts we've talked about? Going once. Going twice. All right, I think we're good. I think we're good to go then. All right, well, in which case, let's get started with some rationals review. There will be another progress assessment this week. That was the last thing I wanted to mention. I'll talk about that more at the very end. So do make sure you pay attention. Do make sure you take notes, and then we'll talk about that. All right, so if you remember, when we dealt with rationals in the fourth quarter, the very first topic that we started talking about together was graphing. Okay. And an example of a function that you may have been asked to graph may look like this. Ready? F of x is equal to, let's do x squared plus 2x, all divided by x squared plus 3x, and then a plus 1 on the outside. All right. So if I have to graph a rational function like that, the very first thing I'd want to do before I find my asymptotes is to factor, if possible. In the numerator, notice I could take out a greatest common factor of x, leaving me with x plus 2. In the denominator, notice I can do the same thing. Take out a greatest common factor of x, leaving me with x plus 3, and then plus an additional 1. Now, the matching factor of x in the numerator, matching factor of x in the denominator will cancel out, leaving me with x plus 2 over x plus 3 plus 1. But if you recall, that cancellation doesn't come for free. It does create what's called a hole in the graph, and that hole exists at x equals 0. The reason why it's at x equals 0 is because we just crossed out a factor of x. 0 is the value that if you plugged it in for that variable would result in dividing by 0. If we crossed out something like x minus 5 from the numerator and denominator, that would have created a hole at 5 because 5 minus 5 results in dividing by 0, and so on. Now that I've done that, I've done my simplifying, I can go ahead and find my vertical asymptote caused by the divide by 0 case. Your vertical asymptote is x equals negative 3, because negative 3 plus 3 would be division by 0. To find your end behavior asymptote, you create a fraction of the leading coefficients in the numerator and denominator. The reason why you do that is because the degree of the numerator and the degree of the denominator are the same. Notice the numerator has degree 1, the denominator has degree 1. They're the same because they're both x to the first. Now I create a fraction out of these. 1 divided by 1 is 1. Plus 1 on the outside gives me my end behavior asymptote of y equals 2. Question about that at all? All right, let's keep going then. Now I'm going to go ahead and draw in my asymptotes. I'll do that over here. Let's see, trying to structure my graph so I can take advantage of the space here. I think I can do this, just like that. My vertical asymptote is at negative 3 right here. My end behavior asymptote is at positive 2 right here. And now I can go ahead and test some points. If you remember, the points that I want to test are 2 to the left and 2 to the right of the vertical asymptote, just so you can see what's going on, so you can get a visual of what's going on. And don't forget, we'll have to come back and take care of our hole at the end. So since my vertical asymptote is at negative 3, we can go ahead and plug in negative 5 and negative 4 and negative 2 and negative 1. Right? Negative 5, negative 4 from the left, negative 2, negative 1 from the right. I take -5, I plug it into my function. Again, you don't have to plug it into the original once you simplify. You can just plug it in down here. -5 plus 2 is -3, divided by -5 plus 3 is -2, and then plus an additional 1. -3 divided by -2 is positive 1.5, plus 1 is positive 2.5. So I have a point right here at -5 comma 2.5 right there. Next, -4 goes in. In the numerator, -4 plus 2 is -2. In the denominator, -4 plus 3 is -1. -2 divided by -1 is positive 2, plus 1 is 3. It's right there. And you could probably already visualize, if you recall from our graphing discussions, what that looks like. It's a curve that approaches but not touches the asymptotes. And that's why we draw in those asymptotes to serve as guidelines. All right. Next, we do the other side. -2 goes in the numerator. This one's easy. -2 plus 2 is 0, divided by -2 plus 3 is 1, plus 1. 0 divided by 1 is 0, plus 1 is 1. We have -2 comma 1 right here. Lastly, -1 goes in. -1 plus 2 in the numerator is 1. -1 plus 3 in the denominator is 2, plus 1. 1/2 plus 1 is 1.5. Brings us right here. Okay. The very last thing I'm going to consider when graphing this rational function is the placement of the hole here. The hole is at x equals 0. So wherever our curve happens to cross this threshold right here of x equals 0, which is the y-axis, I'm going to indicate that with an open circle. So notice I'm going to draw my curve, approaching but not touching the asymptotes, approaching but not touching the asymptotes, and wherever my curve happens to cross that threshold, I add the hole. And that is a complete graph of that function. Alrighty. Any questions about that at all, even in the slightest? That was a nice little flashback, I think, to graphing. Okay. Oof. The next thing that we did was solving equations. After we talked about graphing in detail, we talked about the hole, we talked about domain and range, at least with the basic examples, not necessarily with the holes because it gets a little more complicated. We talked about the asymptotes, all that fun stuff. We then went into trying to simplify rational expressions. Remember, that's when we had something like a fraction divided by a fraction. We had to find least common denominator if we had to add multiple fractions together. And that discussion eventually led us towards solving equations. And here's a great example of an equation that we may have to solve. Say I have 1 over 3x squared plus 9x is equal to 5 over the same denominator, 3x squared plus 9x, and then minus 1/3. Okay? An expression like that, if we're trying to, an equation like that, if we're trying to solve it, the very first thing you should do, hopefully, is automatic at this point. You're already realizing that that's what we should do. It's to factor. There is a greatest common factor that we could take out here and here. That greatest common factor is 3x. So I'm going to do exactly that. I'm going to take out that greatest common factor of 3x from that first term, leaving me with x plus 3. I'm going to take out that greatest common factor of 3x from the second term. It's going to look the same way. And then I have minus 1/3 over here. Okay. Now I can find my domain restrictions. The reason I want to indicate those domain restrictions is because it helps me better identify and more easily identify extraneous solutions at the very, very end. So the values of x that would be problematic here are x equals 0, because if you notice, I plugged in 0 for x. 3 times 0 is 0, and then times whatever this is would still be 0, and dividing by 0 is very bad. The other value that would be problematic is -3, because if you notice, -3 plus 3 causes the exact same scenario. Okie doke. Now that I've identified that, I'd like to find my least common denominator. My least common denominator, let's see, I have a factor of 3, so I need a factor of 3. I have a factor of x, I need a factor of x. And I have a factor of x plus 3, so I need my x plus 3 in there as well. Okay. Notice that makes everybody happy. The 3's are happy, the x's are happy, and the x plus 3's are happy. Now we can convert all of my fractions to match that least common denominator. We have 3x times x plus 3 here, 3x times x plus 3 here, 3x times x plus 3 here. Okay, that's what I would like to happen so that I can then combine the numerators. Well, what do I need to multiply this first term by in order to get this term? Nothing at all. It already matches up, so we're just going to leave it alone. What do I need to multiply this by to get this? Once again, nothing. Leave it alone. What do I need to multiply this by to get this? This time we need to multiply by the x and the x plus 3. So I take the 1 that's already there, multiply by x times x plus 3. Okie doke. Now that all your denominators match up, we can disregard them and just pay attention to the numerator. That gives me 1 equals 5. And we watch out for this distribution here. Very, very tricky. We're going to do the opposite of x times x and the opposite of x times 3. So that gives me 1 equals 5 minus x squared. That's the opposite of x times x. Opposite of x times 3 minus 3x. Okay? Does everybody understand how we got to that step? All right, fantastic. I'm going to continue right up here just for the sake of space. Notice that I see that factor of x squared show up, and that immediately is like, ooh, got a factor, right? X squared needs factor, but I can't factor yet. I have to first set equal to 0. Notice that the coefficient of x squared is negative. The fact that we have a negative leading coefficient for x squared is not great. We haven't done any factoring with negative coefficient of x squared. I don't recommend that you do any factoring like that. Always want to make that coefficient positive. So we're going to move actually all this stuff over to the left side of the equation in order to make that happen. So we're going to add x squared to both sides. We're going to add 3x over to here, and we're going to subtract 5. So I'm going to do plus x squared plus 3x and minus 5. That's going to give us x squared plus 3x and then 1 minus 5 minus 4 is equal to 0. Now I can go ahead and factor that. It's a trinomial. I need x times x to make x squared. We're multiplying to a negative at the very end, so I need different signs. And let's see, the factor is of 4. That will make that work out. I think we need plus 4 and minus 1. Right, because that will combine to give us my positive 3 in the middle. Now we could say, well, what value plus 4 should equal 0? That's negative 4. And what value minus 1 should equal 0? That's positive 1. Both of these solutions, by the way, work out just fine because if you notice, they're not extraneous. All right, so this problem has two solutions, one of x equals negative 4 and one of x equals positive 1. Any questions or comments on that problem at all? Alrighty, feeling good? Excellent. Thanks, Sean. Sean's like, nope, we are A-OK over here. I'm happy to hear that. So, last but not least, we dealt with a word problem, an application. This is a work done problem, even though we've done 3 different types, the distance, rate, and time, the work done, and the solution mixture. I think the work done are, number 1, probably the trickiest, and number 2, I think they best encapsulate the rational functions setup and rational equations solving process that we've talked about during this class. So that's why I chose to do one of those. Not that the others aren't important. Make sure you do know how to do those. But I think this is a good one to end up on here. So let's go ahead and do it. It says, it takes Madison 3 hours to clean the house by herself. Notice she's working to accomplish a goal. That's why it's an indicator. It's a work done problem. If Tommy helps her clean, they can clean the house in only 2 hours. How long would it take Tommy to clean the house alone? So let's keep track of some information here. I have Madison. I have Tommy. We're going to keep track of their rate per unit of time. In this case, the unit of time is hours. So rate per hour. And we're also going to keep track of their time contributed when they work together. So Madison's rate per hour, let's see. If it takes her 3 hours to clean the house by herself, what would be Madison's rate per hour then? If it takes 3 hours to get it done and she's working at a constant rate, then each hour she would accomplish 1/3 of the task, right? And that's the very important mindset here when you're focused on these problems. If it takes 3 hours, then every hour is 1/3 of the task completed. When they work together, notice they clean the house in only 2 hours. So when they're both working together, when their time contributed is both 2 hours, they're able to clean that house no problem. Now it says, how long would it take Tommy to clean the house alone? Well, we don't know how many hours it would take Tommy to do that by himself, right? So theoretically, it would take X hours. And if it takes X hours, then every hour, 1/x of the work is getting done, right? Think of if we found that it took Tommy 5 hours to do it by himself, well, his rate per hour would be 1/5, 1/5. If it took him 10 hours, his rate per hour would be 1/10 of the house. If it's taking him X hours, then his rate per hour is 1/x. Alrighty? Questions about that at all? Now I can go ahead and set up my equation, and I can say, well, Madison's working at a rate of 1/3 of the house per hour for 2 hours, so multiply, and add. Tommy's working at the rate of 1/x of the house per hour for 2 hours, and together, if they work at that rate, they should be able to clean the entire house. So now we can go ahead and put this all together. We can say this is 2/3 plus 2/x is equal to 1. The least common denominator here would be 3x, right? Because I have a factor of 3 and a factor of x. Keep in mind that this is really 1/1. It doesn't really have to be considered when finding your least common denominator, but don't forget to convert. That's the number one mistake. Don't forget to convert this equals 1 over here as well. All right. And again, with word problems, it's not really necessary to find extraneous solutions because, it's a real life application. You shouldn't have to worry about domain restrictions. You certainly can. If you want to specify that x cannot equal 0, then by all means, go for it. So now I'd like to convert everything to be out of that least common denominator. Once again, don't forget to convert the 1 over there. What do I need to multiply this by to get this? I'm missing an x, so I'm going to throw that in up top. Take the 2 that's already there and multiply by x. What am I missing here? To get from x to 3x, I'm missing the 3, so I take the 2 that's already there and multiply by 3. And what do I need to multiply this by to get this? It's the entire thing, so I put the entire thing up there, multiplied by the 1 that's already there. Now that all the denominators match up, we can disregard them and just focus on the numerators. I can say 2x plus 6 should equal 3x. And now we're back in a happy Algebra 1 land where I subtract 2x from both sides, and we get right away that x is equal to 6. Okay? Which, in the context of the problem, x equals 6 means it takes Tommy 6 hours to clean alone. And that's that. Any questions, comments, concerns about that at all? All right, so hopefully that was a nice review of all the topics we've talked about in the fourth quarter. We have our graphing, solving, and word problems, right? Where we talked about how to graph a rational function, solve a rational equation by finding the least common denominator, and a couple applications of rational equations as well. Now, one thing I want to mention to you before we wrap up here today is the progress assessment. Although we are without our resident senior, we do still have one more progress assessment for the year in Algebra 2. The progress assessment is going to be pretty much exactly what you saw here, a review of one graph, one equation, and maybe one or two word problems, probably 2 word problems, so I could throw an extra, multiple topics on there for the word problems, not just a work done, but also a distance, rate, and time. Okay. One note I want to make about this word problem. One note I want to make about this progress assessment: it will be due on Sunday at 11:59 p.m., as you may be used to hearing. But this progress assessment, sort of our little gift to you at the end of the year, is optional. It is 100% optional. You can complete it if you so desire, and if you do, it will replace your lowest grade for a progress assessment that you've had throughout the fourth quarter. All right, I think that's a great opportunity for you to be able to get one last little boost to your grade if you take advantage of that opportunity. All right. If you don't complete it or complete it and you do worse, then it won't have any adverse effects on your grade at all. But it's a great opportunity for you to complete it, try to boost up one of your earlier PAs that maybe didn't go quite so well, and, get your fourth quarter grade to a place where you feel good about it. All right. So make sure that you take advantage of that opportunity if you need to. Again, I will send that out today to make sure that you have it. It will be due Sunday at 11:59 p.m. as expected. Right? Awesome. I think that's very fair, and I think that should be, make everybody feel pretty good. If you have any other questions or concerns, please feel free to reach out and let me know. We have one more class next time where I'm just pretty much going to go over a couple questions from the summer material for students entering pre-calculus and then probably say our goodbyes. So don't get too sentimental just yet. We still got one more class to go. But I do hope that you have a fantastic rest of your day. If there aren't any questions, I'll linger for just a bit if anybody does have questions. But that's all I got from me. One more Algebra 2 class to get through. We're going to finish on a high note. Thank you so much for everything today, and I hope you have a great rest of your day. Bye, everyone. Have a great day. Have a great day. Yes, have a great day. See you later. Have an awesome day.